Hi, welcome back to the another lecture series in the process control automation. This is Nagarjuna, and today we will discuss about the ladder logic programming using PLC simulator. So today I'm going to discuss about the ladder logic program in a open source software, right? So in the last previous lecture, we discussed about the ladder logic and the basic rules as well as the addressing concept. So what is the significance of addressing and why we should give an addressing to the instructions. Okay, so now I'll show you a platform where you can simulate the ladder logic programs, and this platform is an open source as I mentioned earlier. So only thing is you need to open the Google search engine and then just type this PLC simulation, right? So here is a link, and you can open this link, and this is a simulator. It's very simple and user friendly, and I mean, like, you can able to do the simulation here easily, right? Now, in the previous lecture, I discussed about the bit level instructions: NO normally open, NC normally closed, and output coil. So if you have not seen that video, I recommend you to please watch that video before this simulation, right? So now in this platform, I just show you what are the features available. So here you can see that, so this is the space, the workspace, where you can create all the ladder logic rungs. And here on the top you can see the instructions. So here you can see normally open instruction, output instruction, similarly some timer related, counter related, and also some math related functions you can able to see here. And here in the last you can see some branch. So if you want to create some branch to the rungs, you can use this. And also if you want to create a new rung, you can create over here, right? So so now I'll create a simple rung. So first of all, we need to create the address. So first we need to create some variables here. So I just wanted to create a simple the logic gate. So I just want a is a one simple variable. It's a boolean type. Submit. You need to click on submit. Similarly, b is another variable. Again, this is also a boolean type. So select the boolean and click on submit. And I want to generate one output variable. So q, again it's a boolean type, and click on submit, right? And now here, after creating these variables, now in this run you just click on the instruction. So I'm clicking on this NO instruction here. So I place the NO instruction. Similarly, another instruction here. Before that, to the existing, if you want to assign a variable, so just you can select on this and click A. So it's the first variable, and close. And now select the second one. So here I'm putting this over here and assign B. Done. And then finally output. So output, and assign a Q, and close. Now with this run, you can see that there are two instructions, normally open instructions in series, and followed by an output instruction Q, right? Now once these instructions are placed in the run in a proper places, and then after assigning the address to this particular instruction, then you can good to go. I mean, you can run the simulation. So for that, you just click on this green button. So now the simulation starts. So as of now, there is no inputs for this A and B. So that's the reason why the Q is 0. Now how to give an input? So simple, select the instruction, just click on it. It will be turned as high, and you can see here the state is also turned as true. Similarly, here one of the input is true but not the other one. So that's why no output over here. So if I make this B also true, then you can see that the output turns high. So it's very simple, and you can execute your logics in this way, right? So once again, if I click on this, again it turns as a false, and again. So now both the input instructions are 0 0, so it remains in normally open state. So when I click, so you can see that the color, it got highlighted. So it means it is turned as a closed. Normally open instruction with respect to input, it turned as closed. Similarly B, right? So this is how you can simulate. And once it is done, and if you want to modify, again you can just stop this, and say for example, if you want to add some branch to this instruction, or if you want to create a OR, so that you need to have a branch. So select this branch over here, click on this, so a branch will be created to the run, and across this branch again you can put another instruction, and then you can assign B and close. That's it. So now it's a OR logic. Again, you can run this. In OR logic, any of the input, if it is turned high, then you'll get output as high. So if I click on this A, you can see the output is turned high. Similarly, instead of A, if I make it B, then now you can see the continuity goes on from the branch and the output is high. So in this way, you can create any logic you wish to execute. So I'll just create another simple run. So with this time I'm using a normally closed, right? So select the normally closed instead of normally open. Then I want to have a branch, so again one normally open, and I'll put this instruction over here. You can click and drag and drop, and I want to change this this instruction as a closed, right? And assign the address A, and for this assign the address as B. Now when you look at this logic, you can understand that it is a XOR logic, right? So A B bar plus A bar B, right? Now execute this. Now you can see when A and B, when both are 0, the output is 0. If I turn this instruction as high, then if one of the input, if it is high, then output is high. Similarly, if I turn this B as high, you can click either here or here, because both are the same, both will respond to the same address. So you can click on anywhere, right? So now B is high, so output is high. What if both A and B are high? When both A and B, when both are high, the output is 0. So with this simulator, you can able to develop all the switching applications, and you can verify and you can execute your logics, and you can check the status. And we'll see the some advanced logics in the next session. Thank you.
Like, share, comment, and subscribe VNR Digital Learning Resource YouTube channel.